Okay, so now let L be the derivative of xj multiplied by jk, and the derivative of xk. This is an elliptic self-adjoint operator, that is ajk fx jk, okay, is a n square matrix of functions. Each ajk is in C infinity b, okay, real is a symmetric real symmetric and positive definite matrix. Okay, so let's say that what we told here is that exists b greater than 0 such that for all xi in Rn we have b to the minus 1 normal xi squared, the sum jk, that's 1 of this ajkx psi j psi k is an equal to b normal xi. Okay, so elliptic. And now let h2 of xi be the principal symbol, that is to say jk1 and ajk x psi j psi k. Okay, so the Bicharacteristic flow is the flow of the Hamiltonian vector field h of h2. It will be equal to the sum j equal to 1 and d psi j h2 d xj, okay, minus d d xj h2 d psi j. Okay, so it's going to be the flow of this Hamiltonian vector field, and is denoted by x s x naught psi naught. This is capital psi s x naught psi naught. Okay, okay, so let's write the Bicharacteristic flow of this Hamiltonian vector field. What is going to be the flow? Is going to be first ds xj of x naught psi naught equal to, well, minus 2, the sum k equal to 1 and ajk of x s x naught psi naught capital psi k again s x naught psi naught. Okay, and then ds capital psi j s x naught s naught equal to, well, now it's going to be the sum of n kl equal to 1. Now dxj alk, and now once again we will have x, this, psi k, this again, and here's another parenthesis, and then we will have psi l. Okay, now we consider l of this. Okay, so this will be the Bicharacteristic flow of the Hamiltonian vector field. Then this is for J1 n. Okay, and we will have as, let's say, initial condition that x 0 x naught psi naught capital psi 0 x naught psi naught will be equal to x naught psi naught. Okay, the Bicharacteristic flow exists in the time interval s minus delta delta, with delta equal to delta of x naught psi naught. Okay, and delta depends continuously on x naught psi naught. Okay, the Bicharacteristic flow preserves H2, that is that when you derive dds H2 of, well, x psi capital is going to be equal to 0. That is to preserve H2. And so the ellipticity hypothesis, the inequality with taking in consideration the initial conditions, will be b minus 2 psi squared capital psi is x naught psi naught squared, and now b squared psi naught squared, and hence delta equals infinity. In the case of constant coefficients, H2 of x psi is minus psi squared. The Bicharacteristic flow is given by xe psi x naught psi naught be equal to x naught minus 2s psi naught comma x naught. Okay, yeah, for a general symbol h xi, okay, the Bicharacteristic flow is defined as dx ds dxi h xi and dxi ds minus dx h x capital psi. Okay, so this is the Bicharacteristic flow for a general symbol h of x and xi. So in this case, you can see that one can easily solve this, obtaining, for example, in this differential equation, a constant. Okay, and when you have in this differential equation a constant, you will have that applying the initial condition, psi naught will have to be equal to psi naught. and so the constant must be the constant that we will have in this differential equation, because this h doesn't depend on x, will be x naught, and from there it comes this psi naught. In the other case, well, we'll just have to derive, and when you take the derivative, you will obtain a um, well, the x es, it will have to be equal to minus 2 psi, and so you will have that the x had to be equal to minus 2 psi s. But when we apply the initial conditions, we will have, okay, this has to be with plus a constant, and then we will have that minus 2 psi naught. Okay, now we are applying x in 0 x naught psi naught. That will give us minus 2 multiplied by 0 plus k, and it has to be equal to, in this case, x naught, because the initial conditions are that this had to be equal to x naught psi naught, and so this will be 0, and now we'll have that k is equal to x naught. So this gives us exactly what we were expecting. Okay, here we were considering positive sides. You can reconsider the cases for the absolute value, but it will give the same result.